previously, I showed you how you could find the regression line just using the calculator. But there's times where you're given some certain information and you need to do the regression line from a formula. Now the formula is in the formula chart that's in the textbook that's also posted online. So we're just going to learn how to use the formula. So this is how you would see the regression line on in the formula chart. And of course, this coefficient of x would be your slope. So this is representing the slope. And the formula for this slope would be r, which is your correlation coefficient, times, and then it has s with a y over s with an x. And we should recognize this as our standard deviation of x. Well, this is the standard deviation of y. So that kind of makes sense. The deviation of y over deviation of x would play a part in slope. Change in y, change in x would have something to do with slope. Now the formula for the y-intercept, this is the y-intercept, that one takes a little bit more to think about. It's not as easy to see thinking about it logically, but let's just see what the pieces are. So x with the bar over it, that's the mean of the x's, average of the x's, and y bar is the average of the y's. So you take the average of the y's minus the slope times the average of the x's. So that would be, if I took y minus the slope times the x, would give me my y-intercept. So they're just kind of rearranging the regression line formula by plugging in the average for the x's and the average for the y's to find the y-intercept. Now let's think back on that problem with the golf clubs, golf club problem. We had already found the regression line. It was 3.166x minus 55.797. So what I want to see is if we can use the formula to come up with hopefully something close to that equation. We had also already found the correlation coefficient to be 0.939. Now we need these other pieces of information, the standard deviation of y, standard deviation of x, average of the x's, average of the y's. Well, guess what? We can find all those things in the calculator. So I still have all the data in L1 and L2 from this problem. Now remember, we could go to one variable stats to find the average and standard deviation when we had one variable. Well, we have two. So we're going to go to two variable. And it asks us, do we have our x's in L1 and our y's in L2? We do. So I'm going to press calculate. And it gives me all kinds of good stuff. The stuff I want to know is the average of the x's. So x bar is 101.875. I also need the standard deviation of the x's, and that is, and I'm going to go pretty far, 2.29518, 2.29518. I'm going pretty far so that I get more accuracy. Now, so that gives me all kinds of stuff about the x's, and watch, if I go down a little bit further, there's y. So y bar is 266.75, and the standard deviation of y is 7.741354. 135, oh, that would actually be 55, okay, if I round it up. So I went pretty far on the decimal places to hopefully get kind of close. I didn't write them all down, which I probably should have, but we'll go with it. So let's first find the slope. So the slope is found by taking r, which is 0.939, And we did round there too, so we may not come out exact, but we'll go with it. Times the standard deviation of y over the standard deviation of x. And let's put that in the calculator. 0.939 times, and I'm going to do a fraction, 7.741355, 2.29518. And I got that the slope is 3.167, which is really, really close. 3.166, 3.167, that's pretty close. Now, the y-intercept, I'm going to take the average of the y's, so 266.75, minus the slope, 3.167, times the average of the x's. So you have to find the slope first to be able to find the y-intercept. So 266.75 minus, now instead of using the rounded version of the slope, I'm going to up arrow and use the whole thing times 101.875 to get a little bit closer on accuracy. It's not quite perfect, but it's close, 55.901. It's off a little bit because we rounded somewhere a little bit off, but we're still pretty close to what we needed to be at. So just showing you that you can use a formula, which you might have to do on some of the homework, to also find a regression equation.